The presence of lone pairs distorts the shapes we mentioned earlier because the lone pairs have unbonded electrons, so the repulsion will be maximum. One lone pair causes the plane shape to bend away from the lone pair, and the bend V shape is formed. An example is the sulfur dioxide molecule. The presence of one lone pair with the 3 bonds results in the formation of a triagonal bimedial, similar like we saw with ammonia molecule. 4 bonds and 1 lone pair result in the formation of a seesaw shape with an angle 173. One example is sulfur tetrafluoride. A square pyramidal forms when the central atom bears 1 lone pair and bonded with 5 atoms. For example, in bromine tetrafluoride, the bonding FBRF angle is equal to 85.1 degrees. The presence of 2 lone pairs and 2 bonds results in the formation of a bend V-shaped structure. Like we saw with the water molecule, the oxygen carries 2 lone pairs of electrons and bonded to 2 hydrogen atoms. In the presence of 3 bonds with the 2 lone pairs, the molecule will have T-shaped geometry. One example is bromide trifluoride. 4 bonds and 2 lone pairs form a square planar shape. Linear shape forms when there are 3 lone pairs and 2 bonds. Let's look at this exercise. Predict all the bond angles in these molecules: methyl chloride, chloroethene, and carbonic acid. First, let's write the structural formula for methyl chloride. The central carbon atom is bonded to 3 hydrogen atoms and 1 chlorine atom. Carbon has 4 valence electrons. Each hydrogen has 1 valence electron. Now for the chlorine atom, chlorine has 7 valence electrons, 1 bonded with the carbon, so we need to add the rest of the 7 electrons as lone pairs. The chlorine ion lone pairs exhibit the maximum repulsion between them and the other bonded electrons. The 3 hydrogen bonds, the down ones, and the one at the top is the chlorine, so we expect the shape to be tetrahedral in shape. Remember, tetrahedral angles are equal to 109.5. The actual measured angle, HCCl, is equal to 108. Now let's look at the chloroethene. First, the structural formula. 2 doubly bonded carbons, one is bonded to 2 hydrogens, and the other one is bonded to 1 hydrogen atom and 1 chlorine atom. The chlorine has 3 lone pairs, similar to the previous exercise. Each carbon atom is surrounded by 3 electron densities, so we expect the angles to be around 120. The actual measured angle for CCCl is equal to 122.4, and the angle of the HCCl is equal to 114.2. The last compound, carbonic acid, the carbon is the central atom, bonded to 3 oxygen atoms. One of them is doubly bonded. 2 of the oxygens are bonded to the hydrogen atoms. Notice you have 2 types of angles, COH angle and OCO angle. You can assume that the OCO angle will be larger than the COH angle due to the repulsion between the lone pairs of the 2 oxygens. The actual measured OCO angle is equal to 120 and the COH angle is equal to 109.5. You can see on the right the ball and stick model. The 3 oxygens lone pairs are spaced farthest away from each other with OCO angle equal to 120 and the COH angle exhibits less repulsion with an angle equal to 109.5.